Is that a question?
Yes, sir. I wanted to ask on plus and multiplication.
Yes.
I've actually noticed that plus and multiplication are just commutative and associative. So is it okay to show the working, or you just have to know saying that if
No, no, no,
they
no,
are
no. Yes. You must have show the correct.
all right? Yeah.
You know how you answer? You answer any question in the exam, assuming that the person you're giving your solution doesn't know anything. So you're trying to explain to them so they can understand. That's how we answer. That's why they say show all the detailed information. So now we want to look at question 15. Each of the following operations, 1 up to 5, so this should be 3, and then 4, then 5, is a binary operation on the set of real numbers. So we are told that these operations are binary. Okay. Question A, determine which ones are commutative and or associative. So it's possible that it can be commutative but not associative. To determine which ones be commutative, which one is associative. In part B, for each of the operations, you must evaluate 3 star 7 star 4. For each, you must evaluate that. So now, let's check. Let's start with the first one. Okay. I think it can fit here. Let's start with part 1. So include the ink a bit. So in part 1, we want to check if it's commutative. So maybe I'll need enough space. So let's go to the whiteboard. Okay, so we are looking at question 15. And we are on 1. The operation is defined A star B is equal to A plus B multiplied by A minus B. So to be safe, maybe before we start checking if it's commutative or what, maybe let's try to expand and see what we have. So A times A, we get A squared. A times negative B, we get minus AB. B times A, we get plus BA. And then B times negative B, we get minus B squared. Now this negative AB plus BA, that is 0. So we remain with our A star B being equal to A squared minus B squared. Wonderful. So A squared minus B squared is our A star B. The next question now is, we now start answering. Part A, is star commutative? Is star commutative? So let's check. Star becomes commutative if A star B is B star A. That's what we want to check now. So we have A star B is given already. So all we'll do is to find B star A. Now, how do we find B star A? Binary is about the order. The definition is telling us that, well, there will be 2 boxes. Let's call them seats. There will be 2 seats. Okay, seat 1 and seat 2. On your right hand side, how do you use those seats? Whatever will sit on 1 must be the first thing you square. So you square the first seat minus you square the second seat. Whatever sits there. Now, when we have B star A, B will be here, A will be here. So on the right hand side, B will come here, A will go there. This means B star A is going to be B squared minus A squared. Then now you check, is B squared minus A squared the same thing as A squared minus B squared? It doesn't look like. Okay, if you are not convinced, if you suspect that that is not the case, but you can't tell using the letters, you are free to pick a certain example that you feel can justify your suspicion. So let's say, what would happen if we had 1 star 2? We are going to have 1 squared minus 2 squared, which will give us 1 minus 4, which is minus 3. Is it the same when we have 2 star 1? Let's see, this will be 2 squared minus 1 squared, which is 4 minus 1, which is equal to 3. Now I've justified that the 2, if I happen to switch, the answers will be different. So star is not commutative. Okay, so star is not commutative. We have given the evidence. The next question is star associative? On the same A, is star associative? Let's check. For star to be associative, we want A, star B, star C. So if I do this, I want this to be the same as A, star B, star C. But if you want, okay, if you want, you can avoid A, B, C, because it will look like, because the question has A, B, so where do I find the C? You get confused. Well, you are also free to use any combination of letters. Let's use P as star Q star R. We want this to be equal to P star Q star R. For example, if you want, if you get confused with A, B, where am I going to find the C? You can change all the variables and use P, Q, R, and see if the changing there does not affect your conclusion. Is it associative? So let's pick the left-hand side. We pick P star Q star R. Okay. This means when we say P star Q, we will be saying this is our A, this is our B. So how do they sit? We have P squared minus Q squared. When we go back there, well, if we want, because now we know we need to go back. So can we say this guy is equated to, say, Z? So that when we go back to P star Q, instead of putting this whole thing, we start by putting a Z and say, oh, we are now back with a Z star arrow. Our P squared minus Q squared, we have named it to be Z. So that we can say, oh, this is our A now, this is our B. So we have Z squared minus R squared. But look, where did we find the Z? Well, the Z was P squared minus Q squared. So now we substitute. We have P squared minus Q squared. This is our Z, but then it must be squared minus R squared. We have found the left hand side. We leave it there. We go to the right hand side, where there is P star Q star R. Let's start with Q star R. This is our A, this is our B. So we have Q squared minus R squared. Let's call it Z again. So that when we go back here, we have P star Z. This is our A, this is our B. So we have P squared minus Z squared. Where did we find Z? We named Q squared minus R squared as Z. So we come back and substitute. So we have P squared minus Q squared minus R squared like that. Just here we can compare. Haven't we seen that in the final solution for the left-hand side, if we have to expand this, we have P squared power 2. That would be like P4. But in the right-hand side, final thing, we have a P squared. That is just telling us that the two can't be the same. So you say, oh, then star is not associative. What is the reason? You've done enough work. So that is the reason now. The third part is saying, yes.
How is the R getting the square? Then how are these letters which are in the bracket? Where is the square root? I mean the square coming from?
The square, remember, let's get back here. Every time you have anything sitting in the first set, star, you have the second seat there. Whatever you put on the first seat must be squared. Whatever you put on the second seat must be squared. And then you subtract it instead. So when I have P and Q, this is the first seat, this is the second seat. I must square here minus I square the second. Now, because we still have R, we choose to name this to be Z because we don't know the actual value. So we say, oh, maybe for the sake of substitution, let's name it to be Z. So when we go back, they ask us, oh, you went to solve for P star Q, right? Yes. What is it? Oh, for now, I'll call it Z. So that we have Z star R. So we have found this guy, but it has come in as Z in the meantime. Then it's star R. When I have this, it means this is the first seat, the second seat. But this one is telling us that whatever is on the first seat, square it first before you subtract the square of the second seat. This Z has come in to represent the P squared minus Q squared. So it means that when we get back to the actual Z, it will still have to be squared. So the actual Z is P squared minus Q squared. We put it here. But then Z moves the square. So we have the square outside minus the R below its square. Then we pack our right hand side. When we go to our right hand side, we will do the same. Yeah, so we'll do the same. So we'll have our P star Q star R. So we first deal with this guy, Q star R, where we'll have Q squared minus R squared, and then call it Z. So that when we come back, we'll have P star Z. And then do the P squared minus Z squared. But then we know that the Z came in as P star. So we substitute, but then because it's squared, it still must be squared. Then you compare now. So this very question was saying, after you have done that checking, the B part is saying, for each operation, evaluate 3 star 7 star 4. Now what we have is that A star B has now been simplified to be A squared minus B squared. That's what we determined. So you start by picking what is in the brackets. 7 star 4. So we'll have, this is our A, this is our B. So we'll have 7 squared minus 4 squared. That is 49 minus 16. What we get? We get 33. Like that. Then we come back and say, oh, so it means when we see 7 star 4, we'll be seeing 33. So we go back there and say, we now have 3 star 33. This is our A, this is our B. So we have 3 squared minus 33 squared. 3 squared is 9 minus, what about 33 squared? That is 1089. And the solution is 1080 negative. So we have found the solution. Given the situation there. So the part of evaluation must always be easy. Because you're just substituting. Okay, so we have only managed to do 1. So maybe I can ask you to try 2. So tomorrow our target will be to do 2, 3, 4, 5. I'm sure we'll finish. And then we'll decide on where we go next. So just make sure that you don't miss class because now it started moving. When we finish binary, it means it will take us time to get back to binary. Unless when they are now saying as a quiz, and we feel we still need to retouch. Of course, we'll do the revision of the quizzes for last year. We need B, and then we know how to write. Now we are experienced. So when they say a quiz, you try to avoid the Monday so that we can have a gist of what is happening. And then we'll write when you're ready within the course of the week. We saw that the results were still taken back to our right TGs. So we can use that experience. There's no need of rushing for the Monday and then there are strange things. So it's always easy. But at least it's good to have an idea first of what is going to be within, and then you rush to write. Okay, so let's go ahead and write.